The seventh and final video for this week focuses on probably the last topic that we're going to have in regression before we get to non-regression, things like path analysis and what have you, is the analysis of discrete dependent variables. And typically the way we would describe these is the data that are either binary values for dependent variables or polytomous or multiple values, that those are really logistic regression models. And logistic regression is just a slight twist on ordinary least squares regression that we're covering, and I do intend to provide a lot of detail about logistic regression later on in the semester. So this is just a primer, and this concludes our regression summary. Because remember, week 1 and week 2 of the semester really were just summaries of basic regression. This week is not just a summary of basic regression, but also an overview of a lot of the material that we're going to cover, and but not in the same detail, obviously. These are just 5 to 10 minute videos, and each one of these topics is going to be dealt with in a whole series of videos later on. So, analysis of discrete dependent variables, oftentimes referred to as logistic regression for this example, because what I'm going to have is just a single binary dependent variable. I'm just using C1, and to make matters really simple, I'm just flipping around C1, my categorical variable. That's now my dependent variable, and Y is my continuous former dependent variable, but now it's my predictor. So I'm going to run this, and I'm going to show you why it's really wacky. If you take a look at the results, these are the regression diagnostic plots, you can see that, look at what happens here is we do not have what we would expect from our model, and that it looks like there's a line of values here and a line of values here because these are residuals. And we expect residuals to look like this because what we're trying to do is predict a dependent variable that now is binary, right? And because we're predicting a binary variable, we're going to have values that are around 0 and around 1. So what we want to do is we want to correct for it, because obviously these plots indicate that there's something really wrong. What we expect is a uniform set of residuals where the mean is going to be across this dotted line. We expect the QQ norm plots for the residuals to be right around this line. This is really wacky, and this clearly shows that we have a binary dependent variable, and so does this. Anytime you see these types of plots, immediately you should say, wow, I didn't handle my dependent variable correctly, so I got to go back and change the model. So the more appropriate model to run is a generalized linear model, or more specifically a logistic regression. And a logistic regression in R, you just have to specify what the family function is for the dependent variable. Again, this is stuff we're going to go over later on. And what we're going to do is we're going to look to see what the difference is in terms of prediction, because remember, we expect that these linear models are going to help us make predictions. And if you look here, the predicted model, the prediction from our linear model up here, which is our regular regression, and our prediction from our generalized linear model, or our logistic regression, the correlation of between the predicted values of both of these models is 1.0. Now, that seems to me to indicate that it doesn't really matter whether you run ordinary least squares regression using our basic assumptions, or whether you change the model so that it is more appropriately modeled for the dependent variable. But I assure you that there are vast differences in these two models, and here are the vast differences. One is you can look at the coefficients, and the coefficients you can see are different. In the linear model, That's this first one. The coefficients, this is A and this is B. Similarly, these are the coefficients right here for the logistic regression. And you'll notice that the two A's are a lot different, the two B's are a lot different. And the reason for it is that these are, let's see, I believe they're likelihood ratios, but they could be odds ratios that come out from standard logistic regression or the GLM. And these coefficients differ. Similarly, we're going to have different results if we take a summary of our regression model. We're going to have a significant predictor for Y. And then what happens when we take a summary from our logistic regression? Well, we still have a significant predictor, but our parameters are different. As I showed you, the coefficients are different. And similarly, our p-values are going to differ. So here we have a p-value that's way below 0.05. It's 3.67 times 10 to the minus 12. And here we have a p-value that's 3.8 times 10 to the minus 7th. Now both of these are obviously less than 0.05. But what you'll see is that there's a general shift in the p-values that are associated with these parameters. And those p-values will differ. If we had a less than stellar prediction model, you would find that the logistic regression would adjust the p-values or the significance testing to be more appropriate for the underlying measurement model. And that the OLS or standard regression model, the standard regression model may actually overestimate the relationship or underestimate it. It's a what we call a misspecified model. The only way for us to detect this is, again, to plot our data. So when we have discrete values as a dependent variable, it's wise to model the dependent variable appropriately so that we do not have a situation that gives us regression diagnostics that look like this. The whole idea about doing these regression diagnostics is to make sure that our regression model is appropriate for our data. So this concludes our introduction to the course and to basic regression. And following these videos this week, we're going to run through a lot of exercises. So after you've watched these videos, we have data that are appropriate for each one of these steps so that everyone can get accustomed to running regression diagnostics, understanding what the tools are that we have available, and also how to generate data and how to look at data in such a way that gives you insights into interpreting the regression coefficients. So that concludes week 2 videos. Stay tuned for week 3 shortly.